Welcome to Honors Geometry, Lesson 8.5, Trapezoids and Trapezium. Other quadrilaterals besides parallelograms. Trapezoid can look like this, but the definition of a trapezoid is a quadrilateral with exactly one pair of opposite sides parallel. So in this picture, these would be the one pair of opposite sides that are parallel. They are bases. The non-parallel sides those are called legs. Oh boy. So now, legs can mean three different things. We've talked about legs as being sides of a right triangle. We've talked about them being sides of an isosceles triangle. And now we're talking about sides of a trapezoid. Those are legs also. But it will make a whole lot of sense with the next screen why we actually call those non-parallel sides legs. That's because of an isosceles trapezoid, kind of like an isosceles triangle. That's why it makes sense that we would call those legs. An isosceles trapezoid is a trapezoid with congruent legs. So you've got one pair of opposite sides that are parallel and one opposite pair of sides that are congruent to each other. Now with this isosceles trapezoid, you got some crazy things that are going on. When you draw the diagonals, they don't bisect each other. They can't bisect each other. Because if they bisected each other, then this would be a parallelogram. But it can't be a parallelogram because it's a trapezoid. Parallelogram says two pairs of opposite sides parallel. Trapezoids say exactly one pair of opposite sides parallel. But really, the cool thing about these two diagonals is that they're going to be congruent to each other. These two puppies are going to have the same length. So that's one cool thing about an isosceles trapezoid. The other cool thing about an isosceles trapezoid, like an isosceles triangle, the base angles are going to be congruent. So if this was 85 degrees, then this base angle over here would also be 85 degrees. And since these sides are parallel, these consecutive interior angles are going to be supplementary. That'll be 115. No, it won't. Yeah, that'll not be 115. Wow. That'll be 95. I don't know my subtraction well. So these two base angles are also congruent, 95 degrees. So those are the two cool things about an isosceles triangle, that they have congruent diagonals and they also have two pairs of base angles that are congruent to each other. Moving right along. A trapezium. This is one picture of a possible trapezium. A trapezium is a quadrilateral with no pairs of opposite sides parallel. If I extend these two sides, eventually they'll hit each other way up there somewhere. And if I extended these two sides way off over in that area somewhere, they would intersect. So it's no pairs of opposite sides parallel. Now, the cool thing is, if you go across the pond to the United Kingdom, our trapezoid is their trapezium, and our trapezium is their trapezoid. But there is a special trapezium. It's called a kite. And a kite is a trapezium that has two pairs of consecutive sides that are congruent. So this side would be congruent to that side, and this side would be congruent to that side. But they have to be different sizes, because if these were all 1 tick marks or all 2 tick marks, then that kite would not be a kite, it would be a rhombus. But let me give you a clue. A kite is a rhombus wannabe. It really is. You know why? Well, it's got 1 pair of opposite angles that are congruent. These opposite angles here have to be congruent to each other. Oh my goodness. I got like a little rat picture going on there. That's really crazy. That's not what I wanted either. So this pair of opposite angles will be congruent to each other. You know, just like rhombuses have pairs of opposite angles that are congruent. Not only that, but when you draw this diagonal right here, that thing did not want to cooperate. Let me just draw that freehand. When you draw that diagonal right there, you're going to bisect a pair of opposite angles. Those 2 angles will be congruent to each other, and these 2 angles will be congruent to each other. But on a rhombus, it's both sets of diagonals that bisect a pair of angles. This one, it's only 1 diagonal. And when you draw the other diagonal, it will be perpendicular to the other diagonal. And just like in a rhombus, the diagonals are perpendicular. That's also true. The diagonals of a kite are perpendicular. So that's why a kite is a rhombus wannabe. It could never be a rhombus, but it certainly does want to be one. So let's move on to the last screen for this lesson. Oh, that's a circle. What is a circle doing with quadrilaterals? You know what it is? It's this right here. It's a to-it. And if you ask me nicely, in class I'll explain what this circle is doing in a quadrilateral chapter. So if you ask me about it, I may just get around to it. This does conclude lesson 8.5 in honors geometry, trapezoids and trapeziums.